Hey everybody, Mr. J here. I wanted to go over your lab write-up for the percentage of hydrated crystal lab with you, just in case you had any questions. Um, at home, you can take a look at this video. So hopefully you've gone through and read all this before we did our experiment. It would be kind of in your benefit to go ahead and read through this intro page here again. It talks about the hydrated compound, example of how we figure out percent water in a hydrated compound. This is like we've been doing in class on our worksheets. You will need this when it asks you the theoretical amount of water in the compound that we use. Okay, so we do it just like we've been doing. Remember, theoretical is what you should have gotten, okay, using our data from the periodic table. So this is right here how you would do that. Okay, once make sure you read through the directions again. If you were not here, I do have data that you can use. So come up and see me, and we'll give you that data that I want you to use to complete this lab. You do need that data because you will see questions from this lab on the final unit test. I want to make sure that you know how to do it. All right, on page 3 of our instructions, it talks about the calculations. And the first one, or one of the big ones that we're going to look at, is what's the percent water that you found in your sample that we use. And we do it the same way we have the amount of water lost divided by your mass of the hydrated. Now, this is barium chloride. We probably use something else depending on the year. So make sure you're using the right substance. Times 100. So kind of like your graded test, what you got divided by what you should have got times 100. Now, we got to find these two. Now, we never directly measured how much water you lost and the mass of the original substance. Remember, we massed out our crucible and then we put about 2 to 3 grams in there. So your weights that you had in your data table, if we go over here, so let me get down the bottom here. Right here on the data table was the mass of the empty crucible, and then the mass of the crucible and hydrated compound, right? So if you subtract the crucible out of that, you'll get the mass of the hydrated compound. And then we, remember, waited till we got within 0.01 grams of our final measurements, and then whatever your final measurement goes on here. And so we'll do the same thing with this one. We'll subtract out the mass of the crucible of that, and that'll give you the final mass of the compound. So you have the mass that you started with, the mass of the final, okay? And the difference between those, as we talked about, is your mass of water loss. So that's how you're going to get those numbers. And then here is your experimental error. We talked about this earlier in the year. E minus A experimental minus accepted, or in our case now, the accepted is the theoretical percent. Your experimental is what you got in your lab. And then we can calculate percent error in this, which is your experimental minus theoretical, okay, divided by the theoretical times 100. Okay? So that's the percent error. And then you're also going to, I believe, calculate the percent yield. So let's look at the data table here. Once we should have gotten this part done in class, okay? So mass of the crystallized magnesium sulfate heptahydrate, this is what we started with, powder before you heat it. This is the mass of just the powder itself without the crucible, okay? And then the mass of the water, remember that's the difference between what you started with, what you ended up with. Between the hydrated and anhydrous, the difference in those is the amount of water that was lost. Okay, and then we can figure out percent of water in crystallized magnesium sulfate. This is your experimental amount, so you're going to use the information from above to do that. Okay, and then theoretical percent, we know how to do that, just like we've been doing in our practice worksheets. Okay, experimental error, we talked about that. Percent error, we talked about that. Okay, and then your results that you got from above, you're going to fill in on the chart here. All you have to do is fill in the numbers. And then we get to the questions part. Okay, from above this point, your and your partner's stuff will look pretty much the same. But once you get the question, this is on your own. This is not you and your partner working together. This is individual, okay? I'll figure out what your partner thinks when I read their paper. So this should be done on your own. If you and your partner put the exact same questions, you are not going to get credit for it, okay? This is individual work to questions. Please note it does say it must be answered in complete sentence where appropriate. Okay, so that means complete sentence, start with a capital, has some punctuations, usually in the middle, end with punctuation. Okay. Also note, please, if I cannot read your handwriting, please type your responses. Okay. I want to be able to read this so you know who you are that don't have the neatest handwriting. So please make it readable. So there are, five questions in there. Okay. So um, that is all the lab write-up. We don't have to do anything else. You're going to turn in this packet and go from there. But please remember the question part is your own work. It is not you and your partner's work. So please do those on your own. If you have any questions, please go ahead and ask me or drop me an email. Thanks. We'll talk to you soon.